Let us look at the graph. We have equation 1 written in the form of y is equals to a x minus x1 x minus x x3 x1 x2 and x3 they are x of the x intercept. Second method is where the equation is written in the form of y equals to ax cubed plus x squared plus cx plus, where d the y intercept, because x is 0, y becomes d, so the y intercept. Okay, now the bridge when we have a, so if the value of a, the value of a and value of a, if the value of a is 0, value of 0 is positive, the graph starts like this with a curve down, say concave down, down at the turning point. There is point, highest point for the graph curve. Okay, so it goes up and curves there, highest point goes down, and here at the point of inflection it changes direction, has to go in a curve that goes up. Okay, so if a is positive, graph starts with concave down followed by concave up. Okay, so where the concavity changes, it creates something like that from one curve to curve. Okay, so that is the point of where it changes the curve. Okay, a is less than 0, a is negative, the graph starts with what? Concave up followed by concave down. Okay, again changes where? At the point of inflection there, where the curve changes into a curve. Okay, right, here we have example 1. On example 1, I will just explain how to get this. So I will given a graph that is down followed by concave up. So from here, because it's concave down followed by concave up, you can already tell a has to be positive. Okay, so we are given graph with the x-intercept -5, -1, +2, and the y-intercept 0 and 10. Okay, 10. So we have the y-intercept as 0 and 10. So I use the first equation. First equation, they say, equation 1, they say find value of a. Find value of a. If I find the value of a, come to this equation, I substitute this coordinate y-intercept. The y value here is -10 equals to a into, because I want the value of a, right, into x. X becomes 0. This is 0 on the coordinate. X is 0. X1 comes from here. The x-intercept is -5. So negative multiplied by -5 will become +5. Okay, +5. Again, I do it again for x 0 minus x2. So minus 1 become +1. Okay, good for this one. 0 minus 2. Okay, so now +5 multiplied by 1 multiplied by that -10. Okay, so -10 equals to a 10. Divide both sides by -10. What do you get? Get a equals to 1. A negative 1. It has to be positive. Yes, see, right? It's positive. value of. So here say write the in the form y equals to x cubed plus bx squared plus c. Okay, so we need to find in like that and expand, multiply everything out and simplify it to be like. All right, let us do that. Okay, right here we have the value of a, we have the x-intercept, so I'll substitute there. Okay, I say f of x equals to, what is the value of a? The a is 1, x minus 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 positive 5 gain x minus 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 positive 1 to x minus, right? Okay, so f of x then what? Then y. So this part represents y. Okay. Now I need to expand this and simplify. Okay, y equals, when I omit to write 1 because we know it's always there. So I'm just gonna cross multiply, what you call that, multiply and expand here and simplify. Okay, expand, simplify. So I'll start by the first one, x plus 5. So now this one, I multiply them out. X times x is x squared, right? And x times negative is negative x, right? 1 times x, positive x, 1 times negative. Okay. So now these ones, when I put right terms here, this will remain subtract, that will remain with x here, right? Y equals to, right again, I will write this again here, but I will then deal with this part because they subtract that is 2. I'll remain with negative x, right? Okay. So now proceed from here. So I'll again multiply everything out here, expand. So y x multiplied by x, x squared is b, right? And x multiplied by negative x is going to be x squared, x multiplied by negative x, okay? 5 multiplied by x squared is 5x squared plus 5, 5 multiplied by x is minus 5x, 5 multiplied by negative 10, right? So let's simplify this first term. Group the like comes here. This one y equals to, okay, so I'm just gonna copy this, right there. Okay, so if you look at this now, get this, see that we have x cubed minus x squared, but we have another one here, positive x squared. So these two, negative x squared plus 5x squared, subtract each other, we're gonna remain 4. It's gonna be 5 minus 1 is 4, so we're gonna remain with 4 again. So here we'll, okay, we'll remain with positive 4, 4. Okay, okay, 4x squared by something like this. Get it up to, to, to. Remember, because this part is out because they subtracted part. Right now we still have it x and negative 5x. So this the negative negative they add each other, remain with the negative side. That means we remain with, from here we'll have 7, right? Negative 7x. Okay, so the equation is x cubed plus 4x squared 7x minus 10. So this is the final equation. Okay, so, okay, right. The form they said we must write it in this form. Form is in that form: ax x cubed, 1x cubed, 4x squared, so x 10. Got it the way that I want. All right. So let's go to the next question. Okay, so number 3, they say write the coordinates of the turning point. You have to write the coordinates of the turning point because the graph does have turning point, right? This is a turning point. Here, the chief turning point is the highest point of the graph where it turns and changes the shape. Okay, here's another one. Okay, so we have to write the coordinates of this point. So we need the x value here. You can find the x value and the y value, right? Then that's the coordinate. Again, this side you can find the x value and the y value. You'll be able to write the coordinate, right? Okay. But now before we do that, how do we find the coordinate? How do we find that point? If this one you cannot find the turning point here, you cannot just say it's midpoint of 5 and positive 1. The way we graph, no, you cannot do that. The reason for that is that remember the graph is and then changes the head. So if the point is here, you see that change there because the change you are not accurate because it did not go straight, that it changed because of the point of reflection. So you cannot just say and that divide by no, don't do it out. Right, so we need an accurate way of getting it. So let's look at that. Let's look there. Okay, so before we do this, let me explain something first. How the gradient on the graph works. So the gradient of a horizontal line have a line this. Okay, let's say this is a Cartesian plane, and you have a line, say maybe y equals to 3. Right? This equation here equals to 3. Right? The reason this is y equals to 3 okay, means now the y value here was 3. The reason this line is possible is because it's horizontal, so the gradient for this line is 0. Right? Let's say you have a point here and you have 3 here. Right? So it means the y value here array. Substitute the y value here. You cannot substitute because remember the equation of times is normally mx, right? So in this gradient is 0x plus 3. So whatever x you substitute doesn't matter because this 0 of from the gradient cancels this out. Means all the x values will have the same right. It's the coordinate 2 and 3, 3 here, coordinate 3, coordinate is 3 and 3, right? So let's see gradient m is equals to changing y, changing k. So let's start with the one the y value here, 3 plus 3 minus in here the y value for this point k minus go all over x raised x raised k. So 3 minus 0, 3 minus 1. So the gradient is 0 divided by 0 divided by any number 0, right? The gradient is there. So you can see the a horizontal is a gradient of 0. Horizontal there is a gradient of 0. Okay, so that is point. And if the gradient is 0, and you want the equation what to say x m plus c, right? You take one coordinate, you substitute, let's take 3 and 3, a equals to what is the gradient is 0, what 3 plus c. So this because of the 0 becomes 0, c equals to right. So the equation of the state equals to y equals to 0x plus c, c what 3. So this is 0. So y equals to 3. See, so this shows you helps a horizontal line as a gradient equals 0. Okay. So why am I explaining this? I'm explaining this to understand show you something for the technical. When you have a graph like this, right? You have a graph like this, right? This point here is a point. Point here is a turning point, right? So if you're looking for, let's say you do a tangent line, and what is a tangent line? It's a point, it's a line that touches the graph once. So if you do a tangent line, and this is not accurate, guys, but I hope you get what I'm trying to do. A line touches it once at one point, touches it there, only one. It's a tangent. Okay, what we call it line. Now on a turning point, the tangent line on a point is horizontal. See, horizontal. So if you have a graph and it's that and you want the turning point, you look the tangent line on a graph at the turning point is horizontal, right? So what do you know about gradient for a horizontal line? The gradient for a horizontal line is 0. This is another one point. The gradient for a horizontal line 0. Okay, so that is what I want to show you there. And now here to find the gradient you need point right on a line according so that you can change a. But now this is a tangent, it only touches the graph once and we don't know point. How can we in here for the of this help us find the point where the tangent touches? Okay, so this is where calculus comes in. Because from calculus said earlier on the previous tutorial that if you have a graph like this and then you have two points that say the y value here is fx, right, and you move a distance h, so it means now when you get here the y value here gonna be what? Gonna be the y for f of x plus h, right? X plus So this actually means that if x here was 2, so here the y value when you substitute x as 2, and if you move 3 units to the right, so when you get here, x has to be 2 plus x has to be 5 here. So the y value here is going to be the y value of plus 3, it's going to be the y value of 5. That is what we got earlier, right? Okay, so it means the y value here has to be from there. So if the x value here was x, then the x value here is x plus h, right? So from first principle, if you look at for the gradient, if you want the gradient this point and that point, what do you gradient is m equals to change y over change, right? So let's start with that, changing y over changing x. Y at that point is what? F of x plus h, right? So the y value is going to be the y value of x plus h minus, then for this one, the y value is going to be the y when we substitute x, right? And then all over the change in x, x here is x minus this point here x, right? So this x cancels that x. So m what is f of x plus 8 minus f of x, right? All over h. So when you look at this, what do you notice? What do you realize at this? You see that this comes from, this is similar to first principle, calculus first principle, right? First principle from calculus. So first principle from calculus. So now you would know the gradient is similar to the equation of first principle. So, and we also explained when we do that equation represents the gradient. So this first principle, what when you are deriving, you are actually finding the gradient. So this is equals to f the derivative of x, the first derivative, right? So because when you derive, you actually find the gradient. Okay, so what are the ways of finding the gradient? So gradient, calculate, find the gradient by saying m first change y with x, or you can say tan of or the angle of a straight line. You can say the tan of that angle and you get the gradient of the straight line. Or if you have the equation of a graph like this graph, for example, if the graph is f of x, right, and you want to find the gradient on one point, maybe here or there, but you have to find the gradient. Because remember, if I want the tangent here, tangent now will go like that, because the tangent has to pass the graph one. If I want the tangent here, the tangent has to go like that. It has to touch the graph once. If I want the tangent here, it has to go like that. It has to touch the graph, right? So wherever you want to find the gradient of that tangent, the tangent line, right? You need to derive the graph. So meaning you have to say the first derivative. First derivative. You can, when you derive once, find the equation of the gradient. Okay, find the equation to help you find the gradient of the time line. So wanted to explain that so that we can continue. So now look, we have a turning point here. We have a turning point. It means if I can derive this once, I can derive it once, I will have the equation of the, and what do we know about the gradient of a tangent line on a turning point? Gradient is 0, right? It means I can derive, and then I know that equation is equals to 0, so the gradient is 0. Then I can to 0 and solve for x to get the x value, to get the x value for the turning points. Get the x value for the turning points. Okay, What do I mean by that? I'll show you. Write the coordinate of the point. Write the point. So look, okay, we have a graph that is like this. Okay, the graph was like that. So here, graph was something like that. So it's concave down here, concave down, concave up here, meaning it curves downwards here, curves up here, up, down, concave, down, up, changes at the point of inflection. Okay, so now we need to find t here, point and point. Okay, so let's do that. What did I say about a point? I said the gradient of a tangent on a point is 0. So it means we have to first what? Derive. Because when we derive, what are we finding of the gradient? The equation that helps us to find the gradient. Okay, so let us do that. So say um, say okay, I'll say m. What is m? M. M is the gradient, right? Which is also equals to f of x, xf prime f, right? Which is the gradient. It has to be what? It has to be equal to 0 because the gradient on a turning point, gradient of the tangent line is equal to 0. And why is that? Because the horizontal line on the point there, okay, the line on the tangent line on the point is a horizontal. Get that horizontal line. Okay, what we mean is a horizontal line. We mean that it's like y equals to 3, y equals to 2, gradient is 0. Okay. Now know that we can say f of x, f prime of x has to be equal to 0. So when we derive the equation for helping us to find the gradient equals to 0 because the gradient on a given point is 0. Okay. Now right, let us derive that one. Okay. Let's when when okay, get there. Okay. So here's the equation. Okay. Okay. So of x equals to that. Now we need to derive that and put it to 0 because the gradient is 0 on the point. By looking for it. What you derive is what? Times 1. Okay. Um, so x equals to 3x power 3 minus 1. Okay. So plus 4 times 2, 8. X minus 1 is 1. Okay. Okay. Then else 7. So I have 1 here. 1 times 7 times 7. And x to the power 1 minus 1 is 0. So x to the power 0 to 1 is 1. Okay. So this is the derivative. Okay. And I've just explained here that on the turning point, the first derivative has to be equal to 0. Gradient has to be equal to 0. We're going to use with that. Okay. So write it again. write it there, say equals to 0. The equation of the first derivative, which helps us to find the gradient, but the gradient is 0 only. This is the equation that helps you to find the gradient. This is the gradient of a tangent on a turning point 0 from equal. So that I solve for x, find the x value on the turning point, x on the point. Okay. Now we have it like this. So what you can use your quadratic formula. You can use your quadratic formula. X equals to minus of this minus b is 8 positive 8 plus 1 of x 8 positive 8 c 7 8. Okay, over to a into positive 8. Right? So from there, x equals that x is equals to x equals to 0.4 and x equals to 0.7. Okay. Okay, so now I have the x. So now from here, this means that I know the x value here. I know the x value here, the x value here for the channel. The x value here is negative 3.4, right? The x value here is 0.7. That's how you find the x. What you can do now is on this equation, on f of x, on the equation of x, because now you know the value of x on the graph, you need the y value on the graph. So you substitute them on the original equation for the, not the derivative. The derivative was only there to help you find the x values. Once you find the x values, come to the original equation, substitute them, right? So now we'll substitute x as negative 3.4. I will say f of negative 3.4, right? Then you will substitute it here on the equation, negative 3, 4 cubed minus 4, 3.4 squared minus 7, 3.4 minus 10. Okay, so when you punch this on a calculator, get the y value here being equals to negative this will be 20.8, right? Again, if you substitute, so here if x is that, the y value is 20.8, so it means coordinate here for the turning point, the coordinate here for the coordinate there, here coordinate is negative 3.4 and 20.8, right? That is the coordinate for the turning point there, up there, when x is negative 3.4. Again, you substitute 0.7, 0.7, and then you substitute on the equation, then the y value becomes negative 12.6. Okay, 12.6, and if you point for this part here, what 0.7 and negative 12, 12.6. Okay, so these are the coordinates of the point. Let me repeat this again. I said on the turning point, if you draw a horizontal line, the gradient of that line, of that tangent line that touches the graph once, is called a tangent. To draw a tangent on the tip point, it's going to become horizontal. A horizontal has a gradient of 0. And when you derive an equation 1, find the equation that helps you to find the end of a tangent. Let's say I want to do a tangent at x equal to 1. I will substitute 1, 1. Then I will get the value of m, value of y, and a gradient. So it won't be 0. It only becomes 0 on a turning point. When you substitute on a turning point, meaning here, if I substitute negative 3.4, I will get 0 because the gradient on a point is 0. Then the tangent line, the horizontal turning. So once you derive once, derive only once, get the equation, equate it to 0 because the gradient has to be 0 at that point. Then you remain with this equation, and then you solve for x. When you solve for x, you get two values of x. The first value of x and the second value of x. Those two values, they represent the x value for the turning point. They are the x values for turning x value here for that turning point, x value here for this turning point. Once you have those x values, take them and you go to the original equation of the graph. Substitute on the original equation of the graph so that you can now find the y value. Okay, y value. Okay, hope it's clear. Next. Okay, let us just discuss it when we are explaining it. Okay, the next one says find x value for point of inflection. What is a point of inflection? I explained that a little bit earlier. I said the point of inflection, the graph, is where the graph changes concavity, right? The graph goes like that, see? Then from there it starts to there. So you can see here, line is not straight. Line is not straight. The line goes, it curves outwards, then it starts to curve. So here, the line is, see, there's a change concavity. Curves inwards, and from there it changes, it curves outward. So we know what is that point? The point where the graph changes from concave down to concave up. That point. That point there where the graph changes is what we call point of, right? Point of interest. Okay? The graph changes concavity. Point where the graph changes concavity. Right. Okay. And how do we get that? Get that point, the x for that point, by deriving the graph at the equation twice. So when we do the first derivative, get the gradient. When we do the second derivative, get point of change. Right. So here is the second derivative. Second. Okay. So you derive twice. That is going to be f of double derivative, double derivation of x, okay, equals to 0. So you derive equation twice and equate it to 0, and you solve for the value of x. Okay, where the value of equation is. Okay, so let's do that. Let us do. So let us derive the first derivative. We did derive that equation, right? And what did we get? Got okay, got the first derivative gave us 3x squared plus x minus 7. Okay. Down, copy, yeah, copy this part so that see time inside. Okay, so what I'm going to do, okay, Okay, so this is the first derivative. What do we want for the point of inflection? What you need the second derivative. So which means we have to now derive this one. When you derive once, you get this equation for the turning point. Then when you derive this one that is already derived, you get point of inflection. Okay, so let us derive that. Get therefore the second derivative of x equals to, so this is going to be times 3 6 x 2 minus 1 is 1, so 6x minus 1 times 8 8 1 minus 1 is 0, so x to the power 0 is 1, so it's going to be there. Okay, now here it is, and then what you do is then you put to 0 6x minus, sorry, plus 6x plus 8 equals to 0, right? 8 0, you solve for x. When you solve for x, what do you get? You get 6x equals to negative 8, right? So x is equals to negative 8 divided by 6, or 4 divided or 4 divided by 3. Okay, 4 divided by 3. So the x value for the point of inflection is there, and this is equals to negative x is equals to negative 4 over 3 is 1.3 1.33. Okay, there. So that is going to be somewhere. But the coordinate there, okay, has to be said the x-intercept, have the x-intercept. This was negative 5, negative 5. This was 1. So the point of inflection is somewhere there, where x is 1.3. So the graph changes somewhere. So now it means from here it comes like that, going outside, going inside. So you cannot say negative 5 plus 1 because the graph is not symmetrical. It changes here. And that's why you cannot find the turning point by saying it's just midpoint of x-intercept because of the point of view. So you have to do it the right way that shows. Okay, so that's how you find the point of inflection. Let us go to, okay, here's another example here. Here is another example. Example 2, then ax cubed plus bx squared plus cx minus 5. So from the equation, we can already see if x is 0, y value is 5. It means the coordinate of y-intercept is what? 0 and 5 there. Okay, and we can see here that the graph ends on the graph going concave down, but the turning point is on the horizontal line. The turning point is on top of the horizontal line. So when that happens, it means both the x-intercepts that normally you have it like that, meaning you x-intercept. But in this case, because it moved down, this curve ends here. So these 2 points are now represented here on the turning where x is, and again for this side, x is positive 5, and also and the y-intercept is 0 and 5. Okay, so we have the values, the coordinates of the x-intercept, with the coordinate of the y-intercept. So we can use that method of turning the intercepts to find their equation. Okay, so they say write the equation of x. Okay, let us do that. So we'll say f of x equals to a into okay, x minus it x minus 2 oh sorry x minus 3 okay. That for now we substitute the y value here for point of intercept is negative 5 is 5 minus 5 equals to 3 and the x value is what 0 right 0 minus 1 see that so we can have minus 1 twice explained here these two are now represented at 1 point so this becomes this equation becomes something this here now becomes a for I write it simplified first f of x plus a x minus x 1 and okay it's 1 and 2 1 because it's this one here it represents it's twice touches the turning point so it represents 2 points represents 2 points 2x intercept and their values are just the same point okay so okay like that. So I'll just say square just say square 5 because it's the same it's like you're taking this but x1 is also x1 here so it's just of the same thing so that's why I say okay then last one is x minus x3 okay, okay. So let us substitute we use the y-intercept y is 5 equals to a into x is 0 0 on the intercept 0 minus x1 x2 what negative 1 it's going to be negative negative because it comes from negative positive positive squared and then you go there x is 0 minus 5 positive 5 positive 5 there, there. So from here you can see 1 squared is 1 and 5 is negative 5 5 okay so this is negative 5 equals to a into 5 right so from here you can say therefore a equals to 1 okay now we know the value of a so once we know the value of a what can a is 1 just substitute here simplify get the equation that they want us to give a of x equals to f of x is equals to f of x is equals to a1 into x plus 1 because I said minus because it plus that and square there to there to 5 okay so I just need to expand this and write it in this form okay let me do that. Right, so the simplification here, the f of x equals to, for me, because we know all of there, we'll expand this bracket. Let me write first x minus 5. Now we'll expand this one in the square, so it's going to be twice the same thing, right? So when you expand it, the x squared square is 2x plus 1. Okay, so now I need now x equals to x multiplied x squared is x multiplied x is 2 squared squared x multiplied with 1 is x. Okay, 5 x squared is 5 x squared. 5 x is x 5 5 multiplied 5. Simplify here, group f of x equals to 5. Now get the left times 2x squared 5 squared. So they subtract each other in meaning what? Array. Okay, this part is now gone. X here, okay, minus 10x. They subtract each other. Okay, so the final equation now of x is what? X cubed minus 3x squared is x is 5. Okay, so it's in standard form. Okay, found f of x. Okay, let's go next question. Okay, two of that they say write the x value of the turning point at local minimum point. Okay, local minimum point. What is a local minimum point? The graph has two turning points, right? So the local point is where the graph is turning. So where the graph changes direction. Okay, so here when you start from here to the left going to the right, you realize the graph, the y value, it goes up, it goes up, it goes up. When it gets here, it reaches the maximum, right? And then after the maximum, it starts to decrease. And when it comes here, it reaches the minimum point. Right after reaching the minimum point, now goes back to increasing, right? For me, this is the max point, and then this is the minimum, right? So these are two local points. So this is the minimum local point, turning point. They are both turning points. So this is the maximum because while graph was increasing, and then that is the highest point of the before the graph turns to change the And this one here is the minimum point because it is the lowest point for the graph or where the graph tends and changes the chain. Okay, so this is the minimum local point. That is the point. Now they tell us to find the x value of the minimum local point. Local point is this one because it is at the bottom. It is the curve at the bottom. The curve up is curve down is minimum. Okay, so this is the bottom one. So we want the x value for that. We want the x. How do we find the x value of a turning point? I explained on the previous example. I said derive the graph once and equate the derivative 0 because the tangent point, the tangent line on a turning point is a horizontal line. The gradient of a horizontal line is equals to 0. And when we derive once, we are actually finding the equation of n. That helps us to find. But no, the gradient has to be 0 because it's n. Okay, so we have to derive this. Okay, okay. So what I'm going to do is copy this so that we next right and can then derive. Okay, put it here. This is the equation. Now we want local point. What do we do when we want the local point? Derive once, right? Derive once, and we equate to 0. Okay, let us find f of x equals to, okay, so this is going to be 3 times 1 is 3, x 3 minus 1 is 2, 3x squared there, then 1 is negative 2 multiplied by negative 3, 6, x 2 minus 1 is x is 1, that minus 9, 1 times 9, and 1 minus 1 is 0, so x to the power 4 is 1. But what I see from this, that can be simplified and divide everything by 3, right? So I'll equate it to 0. I'll say 3x squared equals this, which is there. Equate it to 0. Why? Because the gradient is 0 at the turning point. Gradient is 0 at the turning point. So I can see here all these terms are perfectly divisible by 3, right? I'll divide everything by 3. I'll divide by 3, I'll x squared squared x, okay, equals to 0. So now I can just factorize this, find the x values. So x, so c is negative, so I have current positive and negative, and go and take the sign of 10. So the vectors are 3 and 1. So I have positive x minus 3 equals to 0. Okay, for x equals to, actually I should say x is not equals to, so your x equals to 1 and x equals to positive 3. Okay, so I have two x values for the turning point, and they said they want the local, right? So let us look. Okay, the local minimum is on the side where the x are positive, so the x has to be positive side. So it means the x value here has to be 3. Okay, so the x has to say here. Uh, so the minimum local point where x is equals to 3. Okay, say point where x equals to positive. Okay, positive on the positive side. So we have 10%. Right. So take one because we can see that the graph, okay, on the side where x is positive. Okay, from the x. Okay, let's go to the next. Another question. Here is another question saying to us f of x is f of x given as x cubed plus bx squared plus cx plus d. Okay, so we are already given the value of a. Remember, this has to be ax cubed. Now we are given the value of a. A is what? A is 1. See, a because it's not means it's 1. Okay, and they're saying to us, here's the graph. They're saying to us, m and n are reaching points of this graph. M and are reaching points of the graph. Saying x intercepts are 3 and 0, 3 and 0 because the x is 3, y will be 0, x intercept, and another x intercept what is at m because the turning point, okay, graph turns on exactly on top of the x-axis line. Okay, so they say show that f of x is equals to x cubed minus x squared minus 5x. Okay, so we prove that this is the equation of the m. So what do we know? Know the value of a, right? That we know the value of a, and then here know the x-intercept. We are also given k, the y-intercept. So the only thing we need to find the x value for this 10 point xt, right? So here this is xt and yt. Find the x value. Okay, so use that equation that we are used to do this. So if I right from scratch, I'll just go from somewhere. Okay, it's this one because the graph turns exactly on the x-axis line, so it must have this square. Okay, so we can go and here we have f of x. So that then I'll say f of x equals to, but a we know, right? A is 1 because it's given the 1, right? Whatever. So the value of y here, value of y for the y-intercept is 3, a is 1, x is 0. Now the x value for the turning point here is xt, right? Xt. And what do we know about xt? Xt is on the negative side. It means it is negative. So when you substitute case with negative, so I'll have negative of xt because it's on the negative side, so it's positive, right? Say x, okay, positive x xt, okay, squared because it is on the line, so it's a turning point on the horizontal line, so it's twice 1. Okay, I'll square it. Then I will do for this one x is 0 and x3 x-intercept here is 3, right? 3. Okay, so from here I can solve for xt. Okay, solve for xt from here. So I'll have -3, -3 dividing each other, I'll have 1. So 1 also 1 equals to xt. Okay, 1 equals to xt squared. 1 equals to xt squared. So 1 equals to xt squared. Okay, to remove the squared, what do? I apply the square root. When I apply the square root, I'll have plus or minus, right? I'll have plus or minus. Uh, so I'll say xt is equals to 1. Okay, so I'll have plus or minus, but I have to take one that is equals to 1. Why do I have the one take the one that is equals to 1? Because when I substitute here, it's positive. If I take the one that is negative, when I substitute here, it's like I'm saying uh, it comes with negative. Because I'm seeing 1 because I already accommodated the negative when I was substituting. So now when it comes to 1, it's gonna make sense here. Because if I bring it as -1, it won't make sense because it's like on the positive side, right? So I just take the positive, put it there. Okay, so now I have xt. So if I have xt, I can now proceed to find the equation. See, find the equation. And copy this. Okay, so I'll just proceed here. Okay, f of x in 1, right? X minus -1, so x plus 1, right? For the any point here, the x except for that side, and here x minus 3. Okay, like this, right? So what I need to do here, that I need to expand, simplify, right? F of x is equals to, oh, I'll start with this one minus 3, then I will expand one. So this one will become x squared plus 2x plus 1. Okay, so now again multiply out here to expand. Okay, so x multiply that squared x cubed plus some x squared. Okay, times 1 is x, plus x in negative 3 times that x squared is negative 3 x squared, 3 times 2 is 6, negative 6x, 3 times 1 is 3. Okay, from here I just put the like terms there, terms. Okay, so I have 2x squared, I have x squared with a 1. Okay, so cancel out that. Okay, and for x here I have 6x there. Okay, so again they subtract each other 5 out. That is the equation. So if you check here, you realize this equation that we have same well, is the same as the one that they said is the check. Only same because you have x cubed here, x cubed and x squared minus 5x 5x 3 negative 3 3. So it should what asked us. Okay, let's go to the next question of this. You are asked to find the coordinates of n. Okay, or you are asked to find the coordinates n. What is n? N is a turning point. It's a local, right? It's a local point. Turning point on the concave arc where the curves are. So what do you find? What do you find the turning point? We have to derive x and 0. Equation here. Put it in so that we go and derive it. Okay. And then that is what you put to find the point to test if once weight that equation of the to 0 because our gradient is 0 on the turning point. Okay, then we have derivative of x equals to, so this will be 3x squared x squared, okay, this will be minus 2x x, this will be 5 5. Okay, then we need 0 0 try to factorize this. Okay, so how do you factorize something like this? You can use the quadratic formula or you can use the method I'm applying. Okay, so first start by applying A with C. So you now say 3 multiplied by 5, 3 multiplied by 5, okay, so multiplied by 5, it's 15, right? Okay, it's 15. So now, after you get that, look, want the vectors of 15 that when you multiply them together, but when you add them together, they achieve. Okay, because what 3 and negative 5, because 3 times negative 3 times negative 5, right? Remember, this comes from multiplying the A, C. So I'll say A with C get D. Yep, that's the first thing. So once you get C, you get 4 perfect numbers that will multiply them that number, but when you add them, okay. So it's negative is 5, sorry, it's 3 and 5. Because 3 times 5 is 3 minus plus 5. When you add them together, okay, fine. So then you come here, then you write, okay, copy side back, so you write here, and now you change this middle term to one middle term. No longer write like write it to 10. Instead of saying negative, say 3 minus 5. Then it's gonna be positive 3 now you positive 3x plus positive 3x plus 5x, right? It's 5. Okay, so you see positive 3x and 5x. When you work them out here, they give negative x. The ones that we put here. Okay, so I'll just simplify that. Then from here, from these first two terms, we take out the common factor. So from here, I can take 3x out. I can take 3x out here. Take 3x out, common factor, and what will I remain with here? I will remain with x plus, what do I remain here with when I take 3x out? I remain with 1. Okay, I took the common factor out of only these two, right? Because they had a common factor. And again, these ones they also have a common factor. What is the common factor for this? 35. From taking 5 out, and what do I remain with if I take 5 out? I remain x here. What do I remain with if I take 5 out? I remain with positive 1. Okay, equals to 0. Now these factors same, so I take this one now out as a factor because it is here, it is also there, so I take it out as a factor. See that? I'll do that. X1, take it out as a common factor, x plus 1 into, now if I take this one out as a common factor, what do I remain with? 3x is 5. Okay, 0. Okay, and now this is how easy, because this one is x equals to 1 and x equals to 3 divided by 5. I'm sure you can see that. 3 divided by 5. Okay. 5 divided by 3. Sorry. 5 divided by 3. Okay. So now they said find the coordinate of n, and we saw that n is the local minimum. N is on the right side, on the side of x. N is on the side of positive. It means n has to be 5 over. Okay. N 5 over. N is this one. The x value for n is this one. Okay. So n is on the positive. So say here I'll say for n, okay, x equals to 5 over 3. Okay, so now I have the x value. I take the x value and go to the equation, the original equation f of x here. Say f of x, where what is x? 5 over 3. Substitute here to find the y value right from here. Substitute y value. And if you substitute x here as 5 over 3, what do you get? You get negative 6 over 7. Right. So this tells us that coordinate of n, n is what? N is 5, 3, and negative 56 over 7.